Welcome KringleCon attendees to HTTP2 because 1 is in fact the loneliest number. My name is Chris Elgee. I work at Counterhack Challenges, building things and breaking things. I'm also in the Army National Guard. I'm on the Twitters. I have too many E's in my last name, some certs, and a singing Justin Bieber toothbrush. Chris Davis and I are going to talk to you today about HTTP 1.1 and 2.0 and some of the differences there because 2.0 is a technology that most of us are less familiar with, but it's really pervasive, and we'll look at that going forward. So each created about 18 years apart, and kind of preceded by HTTP.9 and 1.0, but really .9, 1, and 1.1 aren't terribly different, at least in terms of the aspects we're going to look at today. So with 1.1 and 2.0, they're both going to be available in any browser you're using. Safari, Chrome, Firefox, Edge, whatever. They will speak both of these technologies. Now with 1.1, our headers are all ASCII. They're all human readable. Each header is a line of code, a line of ASCII text. Where with 2.0, it's all byte codes. It's binary. So we're not able to read it anymore, but it's computers talking to computers, so that they can be a little more compact in how they communicate. So that saves a little bit of overhead there. Also, with 1.1, it's really a connectionless technology. Your client, your web browser, asks for one file at a time and gets it back from the web server one file at a time. Where with 2.0, it is connection oriented. We'll see the term stream pop up a few times, to where basically a web server can send a bunch of files at once with a single TCP handshake and a single teardown at the end. With 1.1, we do still have some unencrypted, just regular HTTP websites, but of course, most things we're doing anything sensitive on are going to be TLS, and that's your social media, your email, or whatever. With 2.0, the RFC actually allows for an unencrypted HTTP2 connection, but no browser will speak it. Really, the only tool I've found that will speak unencrypted 2.0 is curl, and we'll play with that here in a little bit. And finally, with 1.1, that's absolutely totally available in any web server you're going to go to. You really have to contrive an instance where that wouldn't be available. Whereas with 2.0, it isn't completely available across the entire internet, but with any top site, with most top sites, it's going to be up. So if we look at the top Alexa sites that fit on my slide, all but 3 are speaking 2.0 already. And if you think about it from the perspective of these major providers, there's a cost savings there, right? With these binary headers, with fewer TCP handshakes and teardowns, there are a few fewer bytes in each transaction for a user, which when you're dealing on the scale of these type of systems, then that could be a significant cost savings in terms of network infrastructure. So pictorially, we can sort of think of it this way, where with 1.1, we would request a URL like slash or index, and then we would get that HTML file back from the server. And then since that file referenced a JavaScript a script that needs to be added, then we request it, we get it back. It references an image, we request it, we get it back. Maybe some CSS, request it, get it back. All as individual connections with a 3-way handshake, the push of the file, and then the 4-way teardown. With 2.0, it is simpler. It's a little more kind of fancy in how it does things, but there's a single request for slash or index, and then the server can send back all the files that are necessary in a single push. So again, less overhead in terms of network traffic. To look at it a bit lower level, let's kind of dive into curl here a bit. So we've got here just curl, or give me a website, -v for verbose. Without this, curl would just return the HTML or whatever content comes back from the server. It wouldn't tell us what's going on kind of under the hood. I'm then going to specify --HTTP2 because I want to talk HTTP2, because that's what this talk is about. Then we're going to give it a specific URL, https://www.baidu.com/. That's the website I want. Then I'm going to do this little shorthand for put standard error into standard out. I'm going to do this because in order to show this one screen at a time, I'm going to pipe standard out through the command less. Without putting standard error into standard out, we wouldn't be able to see the information that curl is going to give us about the handshake stuff. When we curl verbosely, we get the TLS handshake information and all that connection errata in standard error. So if we didn't put it into standard out, then it would fly by and wouldn't get caught by the less command. So that's just a little shorthand there again to combine standard error and standard out. So off we go. Our browser, curl, goes ahead and reaches out to Baidu and then offers up a couple different connection methods using application layer protocol negotiation, or ALPN. It's offering H2, which is just shorthand for HTTP2, as you might guess, and then also 1.1. And then goes forward and kind of finishes the TLS handshake. Now notice that these offerings, the 2 and the 1.1, these happen as part of the TLS handshake. This is before any GET request or anything like that. This is while they're still determining how they want to speak securely. So those are the offers. The Baidu server comes back and says, great, let's talk 1.1, some certificate information, and then here curl is showing us the regular ASCII request that we're used to seeing, right? As web app pen testers, we're used to the get and the slash and all this, the host, the user agent, which of course here is curl, and then give me back anything, any type of data. And then the web server responds with a typical ASCII header of 200 OK. Here's some stuff that's coming at you. I don't cache things. Here's a cookie, so I can track your status as we go through. And then, of course, after that comes the HTML. Now it's going to look similar with Google. We're going to offer HTTP2 and 1.1. We'll complete our TLS handshake certificates. And then Google says, hey, let's talk HTTP2, right? I want to save that little bit of overhead, and you're able to talk it, so here we go. Now, this GET request looks a little funny, right? Because we're talking 2. We asked for 2, we got 2 back, and here's our header requesting 1.1. I think what happened here with curl is that it knows we want to see an ASCII header because we gave it the -v for verbose. But of course there are no ASCII headers, so it's got to make something up just for these human eyes looking at it. So it just sort of defaults to showing get/HTTP 1.1, even though this really is a 2.0 request. And we can see that in the response from Google, HTTP/2 200. This is an OK, and of course this is actually coming back and forth as bytecodes, but kind of abstracting as ASCII for us humans. So we see that response. Maybe some headers we're less used to seeing. It's still setting some cookies, right? Because Google's still going to track certain things. And then looking farther down, we get the HTML coming back from Google. So there we have it, just HTTP2 at a high level. And now Chris Davis will talk more about looking at the traffic in depth and decoding it in Wireshark.